All right, we're going to be working on question 3.2a. It says that an arrow was shot at an angle of 30 degrees at your code. I made my code here 20. We have an initial velocity and a horizontal velocity to solve for before we even get started. Excuse me for my voice, I'm just sick. Now, I use sine theta and cosine theta here. I use so and ca to solve for the initial vertical velocity, it's VIY, and then that's VIX, which is 17.32. I then place it up on my Givens chart up here. Right, so VIX 17.32, and there's the acceleration, which is nothing. The acceleration is 0 because there's no air resistance for this chapter. As VIY and AY is equal to negative 9.8. So, start the problem. Part A, it says how high does the arrow go up into the air? So step number 1, we want to solve for dy. Step 2, I'm going to use the vertical column, and I'm going to use VIY, AY, and VFY at the top. That's equal to 0. That's negative 9.8, and that's equal to 10. Step 3, we can just use VF squared equals VI squared plus 2AD. 4, VF at the top is equal to 0. That's 10 squared plus 2 times negative 9.8 dy. So dy comes out to be, we got 10 squared. Bring that over the equal sign, it becomes negative 100. Divide that by 2 and divide that by negative 9.8. We end up with 5.1. Oh. So 5.1 meters. All right, so let's go back to our chart. We now know that dy max is 5.1 meters. We also know that the final velocity at the top, we use that is equal to 0. All right, now the next question says, what horizontal distance does it travel? So I'm going to use a different piece of paper here. So we're going to do for part B, we're going to solve for dx total. Step 2, I'm going to use the horizontal column. The horizontal column, all I have right now is VIX, which is equal to 17.32, and we have AX, which is equal to 0. We're going to, because it's going at a constant speed the whole entire time, we can just use D is equal to VIT, or dx, plus 1/2 AT squared. Because A is equal to 0, there's no acceleration, so that component is erased. Step 4, dx is equal to 17.32, and we're going to solve for time. Here we'll do a bypass. The best way to solve for time right now is to use the vertical column. I'm going to use VIY, which is 10, AY, which is negative 9.8, and I'm also going to use the VFY at the end is going to be equal to negative 10. So when the ball comes back down, or when the arrow comes back down, it's going to have a negative velocity. And step 3, and that's slightly different than what we did to solve for the maximum height, because for the maximum height, the final velocity at the top was equal to 0, so that's slightly different. So just make sure that you're aware of that. So to solve for time, the best way to go is VFY equals VIY plus AY times t. I know sometimes I actually will write in the y's, sometimes it's not really the most important thing to do. Just make sure that you don't mix up your variables from the horizontal and the vertical. The only time that you can actually mix a variable between the horizontal and the vertical columns is with time, which we're doing here. So we have negative 10 equals 10 plus negative 9.8 t. T comes out to be, so comes over, becomes 20. The negative 10 comes over to the other side and becomes a total of negative 20. and divide that by negative 9.8. Becomes 2.041 seconds. Then that comes back over here. And so it's just this multiplied by 17.32. We get a range of 35.3 meters.